Okay, we're going to calculate and measure rotations through torque. Okay, torque is the effect that happens after you apply a force in a specific place at a distance of something we call fulcrum, which is a center of rotation. So you just need to multiply the force times the lever arm, which is the distance between the force and the fulcrum. And the symbol for torque is letter tau. The units for torque are newtons times meters. That means that we need to use forces in newtons, and the lever arm has to be in meters. Okay, not in centimeters, not in millimeters. It has to be in meters. There are two types of rotations. Positive is going to be in this direction, and negative is going to be in this direction. Okay, so let's begin. In this case, I apply a force in this direction, so this bar is going to rotate around the fulcrum, which is in this blue circle. So it's rotating in this direction, and that direction is a negative direction. Okay, because it's a negative direction, I'm gonna put a minus in here in the formula, and then I'm gonna put the force and the lever arm. The force is 13 newtons, so I'm gonna put 13, and I'm gonna multiply it with 25 centimeters. Now remember, we need to work with meters, so I'm gonna convert the 25 to meters, and that will be 0.25. So once I multiply negative 13 times 0.25, I will get an answer of negative 3.25 newtons times meters. Okay, so that will be the torque in this case. In the other one, I have a force that's been applied in this direction that's gonna rotate the bar through the fulcrum or around the fulcrum in this direction, which will be a positive direction. It's gonna rotate like this. So I'm gonna use positive. I don't need to put a plus because I already know that positive stays like that. So I'm gonna put the force that is 85 newtons times 30 centimeters, which in meters is 0.3. So I multiply 85 times 0.3. That gives me 25 newtons times meters. That will be the torque in this other case. Now, what happens in this scenario? I have a diagonal force, so I don't like that. I'm going to convert it into a vertical force by applying sine. Okay, and what about the torque? It's going to rotate in this direction, which is a negative direction. So I'm going to put a minus, then I'm going to put 50, and to transform it into a vertical force, I'm going to put sine of the angle. Okay, that's what you need to do. Then I'm going to multiply that thing with the lever arm, basically the distance in here, which is 4 meters. And because it's already in meters, I don't need to convert it. All I need to do is just multiply that, and I will receive the answer, or I will get the answer for the torque in this case. So I multiply negative 50 sine 70 times 4. That will give me an answer of negative 187.9385 newtons times meters. Now, in this other case, I have two forces. So I need to calculate two torques. The first torque will be with the first force that I see from left to right. It will be 43 newtons. It rotates in this direction, which is a negative direction. So it will be minus, the force is 43 newtons, times the distance, which is 51 centimeters. So I'm going to put 0.51. That will be in meters. So the answer, if I multiply those two numbers, will be negative 21.93 newtons times meter. Now that's only one of the two torques. Okay, that's only one of them. So I need to find the other one. Okay, so to find the other one, I use the same formula again. Okay, now I'm gonna talk about torque number 2, the second torque. So I'm gonna use a subindex 2. And in this case, the second force is going in this direction. It's going to rotate the bar in this other direction, which will be a positive direction. So I'm going to put the force, which is 24 newtons, times the lever arm, which will be 87 centimeters. That is 0.87 meters. So I multiply 24 times 0.87. The resultant torque will be 20.88 newtons times meter. Okay, now those are the two torques that are dealing with the same object. So in order to get the resultant torque, I need to add both of them. Okay, so to add the torque 1 and 2, so it will be torque 1 plus torque 2. That will be the resultant torque, which I'm going to put in here. Okay, formula for the resultant torque is you need to add all of the torques. Okay, if you give me a moment. Need to put this symbol because that's the symbol for sum. Okay, so sum of the torques will be that thing. Okay. Moment so that I can put this thing. Okay, so torque 1 plus torque 2. The torque 1 is negative 21.93, and I need to add that with 20.88. Okay, so if I add those two things, the answer will be negative 1.05 newtons times meter. That will be the resultant torque. That will be the answer for this exercise. Okay, now same idea in the next exercise. Okay, I have two torques in here, so I'm gonna find the first one. Okay, for the first one, this vertical force is gonna rotate the object in this direction, which is a positive direction. So the torque 1 will be with the positive force 200, okay, times the distance, which is 1.3 meters. It's already meters, so I don't need to convert it. It's already there. So I just need to multiply 200 times 1.3. The answer will be 260 newtons times meter. Now the second torque. The second torque would be a force in this direction. I'm going to use sine to transform it into a vertical force. That vertical force is going to create, because it's moving in this direction, it's going to create a rotation which goes like this, and that rotation is a negative rotation. Okay, so I'm going to put a minus because it's a negative torque that you're going to get. Okay, the force is 100, but because it's diagonal, I need to put sine to transform it into a vertical. So 100 sine of 40 degrees times the lever arm, which is 2.7 meters. From the fulcrum to this place, it will be 2.7 meters. So I multiply those numbers. Okay. A moment. Okay, so I'm gonna multiply negative 100 sine of 40 times 2.7. The answer will be negative 173.5527 newtons times meter. Okay, then I need to find the sum of both torques. Okay, so the sum of both torques would be adding torque 1 plus torque 2 the torque 1 is 260, the torque 2 is a negative torque, so it will be negative 173.5527. okay, and if I add those two things, I will get an answer of 260 minus 173.5527. That gives me 86.4473 newtons times meter, and that will be the resultant torque, which is the answer of this exercise. That's how we work with torque. Okay. Okay, either calculating a single torque or calculating a resultant torque of the combination of two or more of them. That's the process for working with torque and rotations.